a strategy. I'm a math teacher, and remember like the whole height thing I like to problem solve? You guys know that some pencil sharpeners totally do nothing? So what do you have to do? You have to turn it, maybe empty it, but there's totally room. You kind of have to turn it the opposite direction of the blades, because otherwise it just kind of keeps going the same direction. And sometimes if you have no friction, that's interesting. You have no friction, it doesn't exactly sharpen the way it needs to now.
Now it's not even working.
Now it's not even working. How did that?
Oh,
it's good to see. So I'm kind of turning it back and forth to cause some resistance. Now, when I start to feel even with the resistance that it's really smooth, like it's not stopping as much. Alright, cool kids. There was a life lesson in there somewhere about how when we have resistance, sometimes we grow stronger. But anyway, for right now, let's get to math. Math has life lessons.
Sir, when's the next quiz?
Oh. Alright guys. On RunWeb all week there's been, like in the homework section, actually no, in the class section, there's been a weekly homework quiz, like every week on Friday. So we do have class tomorrow, it is a Friday. But it's not going to be on section 6.6, it's going to be on section 6.5. Because that's where we did the majority of our homework this week. So we have our normal homework quiz, not the test. Our normal 3 to 5 questions on homework problems, which is why I'm going to go over the worksheet questions that we have in a second. Because remember, it can come from the bookworks or the worksheet. So thanks for asking and just making sure. But yeah, we'll have our normal little homework quiz. I know last week was weird because we had a test. As you guys are writing down notes, I asked you to compare the two and find the pattern. Find the pattern. So were they the same or different?
Different.
But they started the
Same.
But then they diverged right about the third. Ready for some vocab?
Yes.
They went differently right about the third term. Okay. So first of all, you guys have heard me use the word sequence, right? These are both sequences. Sequences of numbers. And you just heard me say about how they both went different at their third term. So even though they started the same, well, they're going different directions. They're both growing, right? They're both growing, but how are they growing? Did anybody figure out a pattern that can explain each jump from one term to the other in the first sequence? Daniel, what do you see?
Adding by 2.
You guys agree? Every jump, plus 2, plus 2, plus 2. Okay. So is it growing? Yes, but in a linear way. If we want to like attach to it some sort of name that we're used to in a linear way. And then, Jerry, what do you see for the second one?
Multiplication.
Multiplication by 2. Andrew, did you have both of them?
Yeah.
Good. And the other Andrew did too. Man, you guys are just so similar in the seating. Times 2. I have to figure out a way to distinguish you guys. You guys need to tell me if you have other nicknames.
Bosch.
Oh, Bosch? Can I just do that? Okay. So I have plus 2 on one side, I have times 2 on the other. Now, here's the dealio. How hard was that to see? Okay. So maybe this section isn't too bad. Come on, have some faith. It's just the beginning. So, hold on. Remember how I was kind of like doing some vocab on the page before? So this is the 2, 4, 6, 8 guy. The 2, 4, 6, 8 guy. In. Hi. Okay. 2, 4, 6, 8 guy. He's called, well, some people would say arithmetic sequence, but that's kind of weird, right? It doesn't look like arithmetic. It doesn't look like arithmetic. So I don't mind if we call him arithmetic. It kind of makes more sense. It doesn't sound all weird and newbie. And it makes way more sense how it's spelled, too. So an arithmetic sequence, a sequence where each term, hey, you guys have seen, or at least heard me use both words, right? A sequence, okay, numbers with commas, I guess. A sequence where each term, okay, each piece, is found by, ready? You guys are highlighting, color-coding kind of person. I would make a big note of arithmetic sequences, needing adding. Arithmetic sequences are all about the adding. Adding the previous term by an identical constant. You guys noticed it was plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. It's adding by the same number over and over again. And guess what? That same number being added over and over and over again is called a constant because it's one single number. He has a name too. So the whole sequence is called an arithmetic sequence. There was a pattern of adding, and what we call that number being added is the common, yeah, it's in common, all of them are doing it. Difference, because what's 4 minus 2? 2. What's 6 minus 4? 2. What's 8 minus 6? 2. Difference means subtraction. So what it's saying is, anytime you subtract any two terms, you get this common difference due. But the nice thing is you guys can actually identify him, hopefully fairly easily, by just saying, oh, I get it, plus, 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 who? 2.
Oh.
So common difference, we call him D.
D.
For difference, it makes sense, yeah? D for difference.
Common.
If he's not in common, he's not an arithmetic sequence. Actually, he's not really a special sequence at all. He might still have a pattern, but not this guy. So, an arithmetic sequence has a pattern. What kind of pattern?
Adding.
Adding by
2.
2.
a common difference, which in this example was 2. Cool? So, he's arithmetic, and he has a common difference, and a common difference is 2. Dun, 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 dun. So, we had this sequence, but didn't we have another one also? Let's talk about the other guy. The other guy was 2 and 4 and then 8. 2 and 4 and then 8. So 2 and 4 and then 8.
Times 2.
Where's your name? Yeah. What are we doing right now? So where's she? No. Go to section 66. But remember, there's a notebook grade that's missing from you. Okay. Where to get them online? It's okay. Do you know where to find the notes online? So here we go. What's this guy's name?
Geometry.
Question. Which one did you guys learn first? Did you learn arithmetic or geometry?
Oh, arithmetic.
Yeah, arithmetic. Adding and subtracting in elementary, right? Geometry, well, most of you technically haven't made it to like the high school class yet. But you've learned little bits and pieces of geometry, like shapes and areas, stuff like that, perimeters. But anyway, you definitely learned arithmetic before geometry. Let's see if I can help us remember who's who. What's the pattern with geometric sequences?
Multiplication.
Yeah, you saw that keyword, right?
Yeah.
Because with our example down here, we saw that it was times 2 every time. You guys saw that pattern so fast, and it was awesome. Times 2, times 2, times 2. What's the name for this dude if it's the common multiplying guy? Ratio. Now, you guys are in algebra. You guys are in algebra. If you, no, hold on, this is calculus. Kind of more like harder algebra, what you see on the board. But hold on, pay attention, and my back is here. Here we go. In an equation, if you saw addition, how would you undo addition?
Subtraction.
Subtraction. So, for an arithmetic sequence, you're adding a number over and over and over again. And what's the name of that constant called? Constant. Common difference. Addition goes with subtraction. Addition goes with subtraction. But this one isn't called a common difference. Subtraction doesn't go with multiplication. What if I was to change this? And instead of saying x plus 2, what if I was to say x times 2? Or we would write it 2x. That's the common way. How do we undo the multiplication? Multiplication. Dividing. Do you guys know the snazzy name for division?
Quotient.
Yeah, that's actually one name. You're right. But it's not common quotient, it's common ratio. Because a ratio puts a top over a bottom like a fraction, and that shows division too. So It's not quite the normal quotient name, but it is technically still a division-ish idea. So the name kind of comes from the undoing of whatever's going on in the pattern, if that's something that would help you remember it. I don't know. For some people, yes. For some people, no. But for this one, oh, I can't call it D for difference. I need to call it, what do you guys think? R for ratio. Good. So who was the other sequence? The other one, not this one, the other one? Arithmetic. And what was the pattern?
Plus.
Adding, plus, 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 like we learned adding when we were learning arithmetic when we were itty bitty kids. And then what was the common number called that you add over and over and over again? Common? D. And D is for difference. Cool. And then who's on, well wait, you're reading this one. We can't do that. Who's the other sequence that we just did? Geometric. The pattern is a little harder because geometry is a little harder. So geometric, the pattern is? Oh, you're just stretching. Geometric, the pattern is multiplication. Multiplication is by a common ratio. Sorry, I thought you were stretching when you did. Common ratio. So wait, what's homework going to be tonight?
Common ratio.
Finding patterns and identifying them with arithmetic or geometric and a common difference or a ratio. So, hold on. You guys help me out. What do you see for number 1? And this is a good one to write in your notes because then when you go homework, you can... Subtraction. Oh, okay, hold on. This is kind of like those nasty tables that we had. If it's subtraction, do you guys think we could make this into an arithmetic, a geometric, or neither? Yeah, we can do sorry, I'm saying it right. The arithmetic. We can do the arithmetic one because can't we make any subtraction addition by a negative? Right? Subtraction is technically just addition of the opposite or addition of a negative. So even though it is subtracting, and we could say that, we could technically say we're adding negative numbers. So here's the dealio. It is arithmetic. You're not multiplying. It can't be geometric. And there is a constant, so it's one of these dudes. But who's my common difference? And to be honest, guys, do you see how? Do you see how the very end of this says explain? Did you write it like a paragraph? No. For me, explaining is going to be telling me. Explaining is going to be telling me whether it's a difference or a ratio. So if it's a difference, it's arithmetic. You got it. If it's a ratio, it's geometric. You got it. And if you can't do a D or an R, it's neither. So who's my common difference for this one?
-4.
-4. Got him. Okay, how about this dude? Do you see how that's nasty? This looks like dividing by. How could you check and make sure that's true? You can either do 128 divided by 8, or you can do 16 times 8. Either way, you're seeing if it works. Does anybody have a calculator real close they can check? Or any mental mathers able to do 16 times 8 in their head really quick? Carry the 4. 8 and 4 is 12. Does it work?
Yes.
Pretty sure it's a yeah. If you want, you could double check, but guess what? It's a yeah. So it's weird. That was subtracting, but still arithmetic. This is dividing, but still. How can you prove it's geometric? Well, what can I identify? Careful, not negative, but I like the idea. We're going different. We're going opposite, like this one was a negative. But hold on, is it R or D? It's R, right? Now careful, we can't say R is 8. Because if it was 8, it would be growing.
1/8.
Give Levi a chance. He's getting it. Alright, someone was excited. They were like, oh, I got it. Yeah, you're right, 20. 1/8 is going to be dividing by 8. Oh, that's a ratio. It's going to be dividing by 8 every time. Okay, last one. What do we think? What's the pattern? What's the pattern? You're so uneven. What's the pattern? Ooh. What is the pattern? +4? +4 plus. You see the pattern broke down, right? Andrew Swanson, you see it break down?
Yeah, I do.
Because if we just did +4, it'd be great for a couple jumps, and then all of a sudden it fails. Maybe it's times 3 and times.
Oh, I'm stupid.
Okay, I don't honestly know what the pattern is,
Oh,
but
I
it's
know
not
what it
either
is.
one of those, right?
Plus 2 plus 3 plus 6.
Plus,
I mean, plus 4.
right? Plus 4 plus 4 plus 6. What is going on? Or times 3 times something, not 3. Long story short, can we just say neither and be done?
Yeah.
Now, pause. We are technically supposed to explain. So how about we say there's no D or R? Right? There's no common difference. There's no common ratio. If there is a pattern, I don't know what it is. Yeah, it could be. The only problem is I don't have enough to make sure that's the actual pattern. And, well, at least for right now, it's neither one of those. But yeah, there totally are patterns out there that aren't addition and multiplication. But for right now, we definitely can say it's not either one of those, and so we're good. So kiddos, here's the dealio. You ready?
Yes, I'm ready.
That's basically enough for, wait. It's basically enough for homework because at the very end of homework number 19, it's going to ask you one more thing. And what's that one more thing? What's it saying instead this time? Right? Oh, it's telling me it's geometric. That's nice. So it's telling me it has a common R. Who's the common R? For this guy.
3.
Oh, so if it's times 3 every time, then how am I going to get to the next? It wants me to fill in the next 3 terms. But isn't it as easy as just times 3 times 3 times 3?
Yes.
So in this one, I'm not even necessarily, they're telling me it's geometric. I need to find R equals 3. But then they just want me to fill in the blank with the next 3, and that's actually my answer. Now, it does say something like graph the sequence. But guys, if you see that direction in homework at all, I want you to totally ignore it, okay?
Yeah.
Totally ignore the whole graphing of the sequence thing. Here's what I want you guys to do. If you have not yet written down homework, we have about 5 minutes left of class.
Did you write ignore the graph?
Oh, do you want me to write it? Yeah, I can write it. I'm just going to say ignore graphing to this homework, okay? If you guys haven't yet written down homework, you have about 5 minutes to work on homework. But for those of you that did get stuck somewhere on the worksheet, for those of you guys that did get stuck, or there's like a particular one that was super hard for you, I have a couple minutes to go over a couple homework questions. So either you are quietly starting on homework, it's back here on the board. Yeah, you can take a picture as long as then your phone goes away. Kiddos, was there anything on the worksheet, any particularly hard ones that you would like to see? Yeah, Kayla. Oh, yeah. I'm just kind of thinking, I was going to do notes tomorrow, and us keep going on section 6.6. But instead, I think after our quiz, we're just going to work on test questions. I think that's what I'm going to do tomorrow. So tomorrow, instead of us having another book homework over the weekend with the end of the grading period and everything, I think I'm going to explain to you guys the correction form that I gave you yesterday and how it works. Maybe some of you can already tell how it works. And then we're just going to kind of work together in groups, but I'll be walking around the room trying to answer questions so that we can try to finish our test corrections in class. And whenever we don't finish, at least we know what we're doing. And over the weekend, we can finish them.
Oh, definitely. Oh.
Oh, tomorrow? I think they're half an hour each. Because we don't have a lunchtime, and so that takes off because it's only up until noon. And then I think all of the periods is half an hour. Something like that. A little baby nutrition, I think, for everyone. Yeah. So right before lunchtime. So those of you guys that are stuck at school tomorrow, like maybe your parents can't come get you until like 2 or 3, you better bring a lunch, and it's not gonna. I don't know if lunchtime's gonna be open.
No, I'm just not gonna come.
Lunchtime. Yeah. So sorry, it's not called snack time. It's kitchen. Used to be called snack time. Anybody have any of these worksheet ones? Because we have a little baby quiz tomorrow. Anything that we didn't like? No?
How many questions on the quiz? 3?
3 to 5. 3 to 5. Like the 2 bookworks in the worksheet. Yeah, Daniel.
Is it on 6.5 and 6.5?
Just 6.5.
Oh.
Because I don't want you guys having to stress about studying like common difference. Like hopefully homework will be easy if you have your notes nearby, but I don't want you having to study vocab. So just 6.5. So that's good. Let's review 6.5 real quick. Tomorrow on the quiz, if you're given a problem where the bases match, just a quick review, please. Bases match. What can you do?
Ignore.
Ignore the bases Now, careful, you're not done though until you solve for
Yeah.
x, right? But what if you're given something where you have like a fraction? How can we rewrite a fraction?
Flip it and then put
2
negative.
to the negative 1, right?
Yeah.
And then, wait, the bases don't match. What would we really want to do to 128?
Divide.
Break it down and see how many 2's go in. Now, hold on.
27.
If you were given big numbers tomorrow on the quiz, it's not hard as long as you have a calculator. So if you don't have a calculator, we made a big point about how you're supposed to have one. I do have a box with calculators, but you have to get here early tomorrow to make sure you get one, yeah? You can have a calculator on the quiz tomorrow. The bases don't match, make them match after breaking them down. Bye guys, see you later.
Oh, Andrew.
Well, wait. You mean like for like get
Oh, John. Go ahead. Yeah. Wait for me. Wait for me, Everest.
Everybody take a picture of